Hello everyone. So in this video, we shall focus on finding the derivatives of algebraic functions by applying some formulas of differentiation. So in my previous video, I showed you the formal definition of the derivative of a given function defined as f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. Okay, and if y is written in terms of x, then the following notations are used. Okay. Okay, so here we shall let u and v be functions expressed in terms of x, and the following are the formulas of differentiation. For the derivative of constant, that is equal to 0. Then we have the power rule, derivative of u to the n is equal to nu to the n minus 1 du. And then we have the sum rule, derivative of u plus v is equal to the derivative of u plus the derivative of v. And we also have the product rule, that's derivative of uv is equal to u dv plus v du. And then we have also the quotient rule, which is written as v du minus u dv all over v squared. That's v times the derivative of u minus u times the derivative of v divided by v squared. Okay, so let's have some example. For the derivative of constant, we know that the derivative of 5 is equal to 0. Derivative of negative 1/2 is equal to 0. Derivative of pi, which is equal to 3.14, is equal to 0. And then the derivative of e, which is 2.718, that's an irrational number, same with similar properties with that of pi, is equal to 0. And the derivative of pi raised to e is also equal to 0. Okay, next formula, the power rule. So we have the derivative of x squared. So what are we going to do is you just bring this down, okay, here, and then you subtract 1 from 2. So you'll have 2x raised to 2 minus 1, which is equal to 2x. One more. Say the derivative of x cubed equals 3x, then 3 minus 1 is 2. Okay, so that's 3x squared. Okay, next, we have the derivative of x to the 5 is simply bring this down and then subtract 1 from 5. So that's 5x to the 4. Okay, next. So what if we have a constant 2 in front of x? Okay, so we have a numerical coefficient 2 here, and then we shall use this formula. So the derivative of c times u raised to n is equal to c times n u raised to n minus 1 du, which means you just only need to multiply negative 4 to 2, and that will give you negative 8x, and then you subtract 1 from negative 4. So that will become negative 5. Okay, so that will become 2 times negative 4x raised to negative 5, which is equal to negative 8x raised to negative 5. One more. The derivative of 1/2 x raised to 2/3 is equal to 1/2 times 2/3, okay, x raised to 2/3 minus 1. And this will give you, okay, 1/3 x raised to negative 1/3. Okay, one more. Say we have the derivative of 3x to the 4 is equal to 4 times 3, that's 12. And then x, then 4 minus 1 is 3. That's 12x cubed. We have the derivative of 1 all over x to the 4. Now, if you compare number 6 with that of our examples from 1 to 6, you will notice that x, okay, raised to the nth power can be found on the denominator. So algebraically, so we can rewrite 1 over x to the 4 as x raised to negative 4. Okay, so we can now apply the formula. So we have negative 4, bring it down, and then copy x, and then you subtract 1 from negative 4. So that's negative 4x raised to negative 5. And then if you want to express the power of 5 positive, okay, so that's negative 4 all over x to the 5th power. Okay, now, from this example, we shall generate a special formula for the derivative of c all over x raised to n. And this is equal to, so what are you going to do is you just multiply this n to c. So you have c times n, and then you copy x raised to n, okay? And then since the variable x or the expression x raised to n can be found on the denominator, so instead of subtracting 1 from n, we shall now add 1. So that's x raised to n plus 1. And then you will oppose the sign, okay? So that will become negative cn all over x raised to n plus 1. Okay, we shall use this formula. Okay, we shall use this formula to find the derivative of 1 over x to the 4. Okay, so by applying the formula, you have c is equal to 1 and n is equal to 4. So we shall have 1 times 4 all over x. Instead of subtracting 1 from 4, you add 1. So that will become 5. And then you multiply it by negative 1. So the final answer would have been negative 4, yeah, all over x to the 5th power, which is similar to the first method, to the answer on the first method that we used. Okay, next. Say we have negative 2 all over x raised to the 5th power. This is equal to 5 times negative 2 is negative 10 all over x. Then you add 1. So that's to the 6th power. And then you change the sign. So that will become positive 10 all over x to the 6. Okay, next. For the derivative of sum. Again, the derivative of sum u plus v is equal to the derivative of u plus the derivative of v. Okay, so we have the derivative of 2x minus x cubed can be written as, okay, derivative of 2x minus derivative of x cubed. And we know that the derivative of 2x is 2 and that the derivative of x cubed by power formula is 3x squared. So we shall have 2 minus 3x squared. Okay, next item. Oh, yeah. So that's derivative of 2 minus 4x raised to 1/3 plus 5x raised to 2/3. Okay, and then by applying this principle, we shall have derivative of derivative of 2 is equal to 0. And then you use the power formula here. So that's negative 4 times 1/3. That's negative 4/3. Okay, x. Then 1/3 minus 1. Okay, and this is negative 2/3. Then plus 5 times 2/3, that's 10/3. Okay, x. Then 2/3 minus 1, yeah, that's negative 1/3. So we shall have negative 4/3 x raised to negative 2/3 plus 10/3 x raised to negative 1/3. Next. So we shall look for the derivative of 3 all over x to the 4 minus 1 all over x raised to 3/4. Again, you shall recall that the derivative of c over x to the n is equal to negative cn all over x raised to n plus 1. So we shall now have the derivative of 3 all over x to the 4 is 4 times 3. That's 12 all over x. And then you add 1 from 4. So that will become 5. And then you multiply it by negative 1. Minus, okay, 3/4 times 1. So that's 3/4. Then x. 3/4 plus 1 is 7/4. And then you multiply it by negative 1. And you will have negative 12 all over x to the 5 plus 3 all over 4 x raised to 7/4. Okay, next. The derivative of x cubed minus 4x squared minus x all over 3x. You will notice that there is 3x on the denominator. So what are we going to do is you can distribute this 3x each term on the numerator. You call it distributive property of division over addition. And we shall have, okay, 1/3 x squared. So that's x cubed over 3x is 1/3 x squared. Then minus 4x squared over 3x is negative 4/3 x. And then minus x all over 3x is negative 1/3. And then by applying the principles of derivative of sums with derivative of power, okay, so you'll have 2 times 1/3, that's 2/3 x. Then you subtract 1 from here. So the derivative of 1/3 x squared is 2/3 x minus the derivative of negative 4/3 x is negative 4/3. So we shall have, okay, 2/3 x minus 4/3. Okay, yeah, next. For the derivative of product, derivative of the product u times b is equal to u times the derivative of v plus v times the derivative of u. Okay, let's have some example. Let's see. Okay, so we have derivative of 2x minus x cubed times times 2x plus 1. Sorry. And then for this particular function, we shall let 2x minus x cubed be our u, and this is our v. And you know that the derivative of this is 2. Okay, so if we let u be equal to 2x minus x cubed, and if we let v equal to 2x plus 1, and then we know that the derivative of u is 2 minus 3x squared, and that the derivative of v is equal to 2. Okay, and then by applying the principle, that's u dv plus v du. So we shall have, this is our u, 2x minus x cubed times the derivative of 2x plus 1, which is equal to 2, and then plus 2x plus 1 times the derivative of 2x minus x cubed, which is equal to 2 minus 3x squared. Okay, then we shall now have, okay, so that will become 2x minus x cubed times 2, that's the derivative of 2x plus 1, plus 2x plus 1, then the derivative of 2x minus x cubed is 2 minus 3x squared. And then the only thing left to do is to simplify this algebraically. So I will introduce 2 each term inside, okay? And then you use the FOIL method here. And then you will have 4x minus 2x cubed plus 4x minus 6x cubed plus 2, that's 1 times 2, and then minus 3x squared. And then collecting similar terms, you have negative 2x cubed minus 6x cubed is negative 8x cubed, okay? And then minus 3x squared, and then we combine these two, 4x plus 4x plus 8x, and then you add 2 at the end. Here's 2. Then you have, yeah, negative 8x cubed minus 3x squared plus 8x plus 2. Okay, next. Okay, so again, we shall let this to be our u, that's x squared minus 2x plus 1, and this shall be our v, okay? And then we know that the derivative of x squared minus 2x plus 1 is 2x minus 2, and then the derivative of v is negative 1 minus 4x. And then by applying again the principle, that's u dv plus v du. Then you have x squared minus 2x plus 1, that's u times dv, that's negative 1 minus 4x, plus v, that's 3 minus x minus 2x squared times the derivative of u 2x minus 2. And then simplifying further, this will lead us to negative 8x cubed plus 9x squared plus 6x minus 7. Okay, let's have some more. Okay, so this is still derivative of product. This time, we will be differentiating 2x plus 1 and 3x times 3x minus 2. Okay, so again, we shall let u be equal to 2x plus 1 and v is 3x minus 2. And we know that the derivative of u by the formulas of differentiation is equal to 2, and the derivative of v is 3. And then applying the principle, u dv plus v du. So that's u times the derivative of v plus v times the derivative of u. And then simplifying further, you shall introduce 3 each term inside the parenthesis, okay? And same with 2 to be distributed each term inside 3x minus 2. And we shall have 3 times 2x is 6x, 3 times 1 is 3, and then here, 2 times 3x is 6x, then 2 times negative 2 is negative 4. Collecting similar terms, 6x and 6x will give you 12x, 3 minus 4 will give you negative 1. So you will have 12x minus 1. Okay, now, from this given example, we shall generate a special formula when you are differentiating function of the form ax plus b times cx plus d. Okay, so we will generate a special formula for this special type of function. And we shall take note that, again, this is our u and this is our v. And we shall know that the derivative of u is a and that the derivative of v is equal to c. So we shall have u ax plus b times the derivative of v, which is equal to c, plus v cx plus d times the derivative of u, which is a. And then again, you just introduce this inside, okay, same with a, and then you shall have ax times c is acx, b times c is bc, plus cx times a is acx, plus d times a is ad. And then you collect similar terms. These two will be combined, and that will give you 2acx plus bc plus ad. And we shall use this formula to find the derivative of the function of this form. Again, we shall verify this derivative. Say, derivative of 2x plus 1 minus 3x minus 2. Here, or times 3x minus 2, sorry. Here, a is equal to 2, b is equal to 1, c is equal to 3, and d is equal to negative 2. By applying this formula, we shall have 2 times a, which is equal to 2, okay, times c, which is equal to 3, then copy x, plus, then b is 1, okay, and then c is 3. So that's 1 times 3, plus a is 2, and d is negative 2. Then plus 2 times negative 2. You know that 1 times 3 is 3, and 2 times negative 2 is negative 4. And then you shall have 2 times 2 times 3, that's 12x. And then, where are we? 3 minus 4 is negative 1. So we shall have 12x minus 1, which is the same answer when we use the theorems of differentiation. Next, we have the derivative of 2/3 x minus 3 times the quantity 2 minus 1/2 x. By applying this principle, we shall now take note that a is equal to 2/3, b is equal to negative 3, c is equal to negative 1/2, and d is equal to 2. And then by applying this formula, okay, 2acx plus bc plus ad. So a, c, it's 2 times a times c. Sorry, it's 2 times 2/3, that's a, times negative 1/2, that's c, and then you copy x, okay? And then plus bc, that's negative 3 times negative 1/2, plus ad, and that's 2/3, okay? Then times 2, that's d. And then 2 times 2/3 times negative 1/2 will give you negative, okay, this can be cancelled out. Yeah, it's negative 2/3 x. And then here, plus, this is positive 3/2, okay? Then plus, am I right? Yeah, it's positive 3/2 plus 4/3. And then we shall now have negative 2/3 x plus 17/6. Okay, next, for the derivative of quotient, so this is equal to, this can be easily memorized as, you have v du minus u dv over v squared. And let's have some example. Okay, so this time, we wish to differentiate x plus 2 all over 2x minus 3. So here, this is our u, and this shall be our v, okay? And then we have u is equal to x plus 2. Sorry for this one, this is equal to v, okay? V is equal to 2x minus 3. And then du dx, that's the derivative of v in terms of x, that's equal to 1. And then the derivative of v in terms of x is equal to 2. And then applying this principle, we shall now have u, that's, this is v. v, that's 2x minus 3, times the derivative of u, that's 1, minus u, that's x plus 2, times the derivative of v, which is 2. And then again, you just multiply this inside, and then you will have 2x minus 3 times 1. And then 2 times x is 2x. Then we consider this minus sign. So that's negative 2x. Then 2 times 2 is 4. Again, you consider this minus sign. That's minus 4. And then simplifying, this can be equal to 0. So you only have negative 7 all over 2x minus 3 to the second power. Okay, again, from this example, we will generate again a formula, a special formula for the derivative of this function. Say ax plus b all over cx plus d. Okay? And then applying the principle, so you have v cx plus d times the derivative of u, and that is a. Derivative of this is a. Okay? And then minus u, that's ax plus b, times the derivative of v, the derivative of cx plus d, which is c, all over cx plus d to the second power. Again, we simplify this algebraically, and then we shall have a times cx, okay, then plus a times d, then minus c times ax, then minus c times b, and you have this. And then you will observe that acx and negative acx will become 0. So finally, we shall have ad minus bc all over cx plus d square. Okay, and this is a special formula for this type of function. Okay, so let's try to work on this problem again if we will get the same answer by applying this special formula. Okay, I shall rewrite x plus 2 all over 2x minus 3. So here, a is equal to 1. That's the coefficient of x on the numerator. Then b is equal to 2. And c is equal to 2. That's the coefficient of x on the denominator. And d is equal to negative 3. And then, by applying this formula, we have ad. That's 1 times negative 3 minus bc. That's 2 times 2. Okay? And then this is negative 3, and this one is 4. So negative 3 minus 4 is negative 7. And then you just copy the denominator 2x minus 3, then raise it to the second power. So that's negative 7 all over 2x minus 3 squared. Now, one easiest way to remember this is by transforming the coefficients of this function into an augmented matrix of this form. So that's A, B, C, and D. And then you just thought this as a process of getting the determinants of this matrix, okay? So that's A times D, then minus B times C. One more. That's A times D minus B times C. All over, you just copy the denominator, and then you raise it to the second power. So in this case, that's 1, 2, 1, 2, 2, negative 3. So 1 times negative 3 is negative 3, then minus 2 times 2 is negative 4. So that's negative 3 minus 4. So that will give you negative 7. Okay? Next. This is still derivative of quotient, and this time, okay, yeah. So this is our u, and we know that the derivative of u is equal to 2x, yeah. And then this will be our v, and then the derivative of v is equal to negative 2 plus 2x. So we shall have u, that's v, v, 1 minus 2x plus x squared times the derivative of u, that's 2x, minus u, that's x squared plus 2, times the derivative of v, which is negative 2 plus 2x, all over v squared. Okay, and then the only thing left to do is to simplify the numerator. Okay, as simple as that. You simplify this algebraically. You use the FOIL method for this one. Okay, and then you shall have, yeah, 2x times 1, that's 2x. 2x times negative 2x is negative 4x squared. 2x times x squared is 2x cubed. And then for this one, use the FOIL method. X squared times 2 is negative 2x squared. Then you consider this minus sign. That's why it will become positive 2x squared. X squared times 2x will become positive 2x cubed. Again, you consider this sign. That's why it will become negative 2x cubed. Then 2 times negative 2 is negative 4. Then you have this minus here. So will become positive 4. 2 times 2x will become 4x. And then again, do not forget this minus sign here. So that will become negative 4x. And then combining similar terms. Yeah, can you see something that will become 0? Yeah. Okay, so this one. This will become 0. And then the only thing left to do is to combine negative 4x squared and 2x squared. So that will become negative 2x squared. Then 2x and negative 4x is negative 2x. And then plus 4. And then you copy the denominator. Okay, so finally we shall have negative 2x squared minus 2x plus 4 all over the quantity 1 minus 2x plus x squared to the second power. Okay, let's see. Okay. Chain rule of differentiation, this is used whenever there's the presence of two or more operations such as sum, product, power, and quotient. Let's see. Say if y is equal to 3x squared minus 2 to the fourth power and we wish to find its derivative y prime, okay? So that's 3x squared minus 2 to the fourth power. So this is of the form power rule. You recall the power rule. So that is u to the n, the derivative of u to the n is n u to the n minus 1 du. And you shall take note that u is represented by 3x squared minus 2, okay? And then the derivative of your u is 6x. Okay, let's have, okay, so for its derivative, what you are going to do is you just bring this here in front, okay? And then you subtract 1, copy, 3x squared minus 2, then you subtract 1, and then you differentiate 3x squared minus 2, and it will become, okay, 4 times the quantity 3x squared minus 2 to the third power times the derivative of 3x squared minus 2. And then we shall have 4 times 3x squared minus 2 to the third power, and then the derivative of 3x squared minus 2 is 6x. And you shall now multiply 4 and 6x, and that will give you 24x times the quantity 3x squared minus 2 to the third power. Let's have some more. Yeah. Okay, so this time, this is of the form 1 over 3x squared minus 2 to the fourth power. So we shall recall the derivative of c all over x raised to n is equal to negative cn all over x raised to n plus 1. Okay, but this time, this is written of the form 3x squared minus 2, and this will be our x. This is represented on the formula by x. So in this formula, we shall now add on the numerator the derivative of x. Okay, and here it goes. So we have y prime equals, okay, then you have the minus sign here. Then c is 1. 1 times 4, that's 4, okay, times the derivative of 3x squared minus 2, that's 6x, okay, all over, you copy this 3x squared minus 2, and then you add 1 to 4, so that will become 5. And then finally, you have negative 24x all over 3x squared minus 2 to the fifth power. And okay, so that's negative 24x all over 3x squared minus 2 to the fifth power. Whoa. Okay, so we have f of x equals 2x plus 3 to the third power times x minus 4 to the negative 4. Yeah. So in this case, we shall take note that u is 2x plus 3 to the third power. And then du is, by chain rule again, 3, you bring it down here. So that's 3, copy, 2x plus 3, then you subtract 1, that will become 2 times the derivative of 2x plus 3. And the derivative of 2x plus 3 is 2. And then you shall have 6 times the quantity 2x plus 3 to the second power. And then v is equal to x minus 4 to the negative 4. And its derivative is negative 4x minus 4 to the negative 5. Okay, and then applying the principle. So this is your u, this is your u times dv plus v times du. Okay, so simplifying further. So what I'm going to do is I will just use the common monomial factor, and you shall observe that 2x plus 3 to the third power, and there's 2x plus 3 to the second power, okay? And I think its common monomial factor is 2x plus 3 to the second power, and then this one is x minus 4 to the negative 5, and x minus 4 to the negative 4. Then the common monomial factor is x minus 4 to the fifth power, okay? When these two are factored out from the first term, so what is left is only 2x plus 3 times negative 4. And then again, when these are factored out from the second term, the only thing left is x minus 4 times 6. And simplifying this expression inside the bracket, we shall now have, okay, 2x plus 3 to the second power times x minus 4 to the negative 5. And then you just introduce this inside and along with the 6, okay? So we shall now have negative 8x minus 12, okay, plus 6x minus 24. And then simplifying, that's 2x plus 3 squared times x minus 4 to the negative 5. Then times, you add this to negative 8x and positive 6x is negative 2x. The negative 12 and negative 24 will give you negative 36. And then there's negative 2 here. 36, common monomial factor is negative 2. I just throw it outside here, okay? And then this will now become x plus 18. So the final answer, f prime of x is equal to negative 2 times the quantity 2x plus 3 to the second power times x minus 4 to the negative 5 times x plus 18. Okay, next. Oh yeah, again, from this example, we shall generate again the special formula to find the derivative of the quantity ax plus b raised to m times cx plus d raised to n. Okay, and here it goes. We shall let u be equal to ax plus b raised to m, and its derivative would have been equal to ma. M times the derivative of this is a. That's ma times ax plus b raised to m minus 1. And then for b, that's cx plus d raised to n, the derivative of which is nc times cx plus d raised to n minus 1. Okay, then you can just verify this process. Okay, and then following the formula, u dv plus v du. We shall now have u ax plus b raised to m times the derivative of v, okay, nc cx plus d raised to n minus 1 plus v, that's cx plus d raised to n times derivative of u, which is ma times ax plus b raised to m minus 1. And then we shall now use the common monomial factor. Okay, so this is ax plus b raised to m, and this is ax plus b raised to m minus 1, and the common monomial factor is ax plus b raised to m minus 1. And then for cx plus d raised to n minus 1 and cx plus d raised to n, the common monomial factor is cx plus d raised to n minus 1. When these two are factored out from here, so what will left is nc, that's nc times ax plus b. And then when these are factored out from the second term, what will left here is ma times cx plus d. Okay, and then we shall simplify this expression inside the bracket by introducing nc each term inside and ma each term inside cx plus d. And we shall now have ncax plus ncb plus MACX plus MAD. And then you will now combine these two, NCAX and MACX, by common monomial factor ACX are common. So we shall have ACX times the quantity N plus M plus, then we will just combine these two, BCN plus ADM. So we shall have the derivative of this function is equal to the quantity AX plus B raised to M minus 1 times CX plus D raised to N minus 1 times ACX times the quantity N plus M plus BCN plus ADM. Okay, and then we shall verify this. This is our previous example. So in this case, M is equal to 3, N is negative 4, A equals 2, B is 3, C is 1, the coefficient of X, and D is negative 4. And then applying this principle, we shall have f prime of x equals ax plus b raised to m minus 1. So that's 2x plus 3 raised to 3 minus 1 is 2. And then x minus 4, negative 4 minus 1 is negative 5 times acx. A, that's 2. C, that's 1. X times n, that's negative 4, plus m, which is 3. Then plus bcn. B, that's 3. C, that's 1. And n, that's negative 4. Plus A, that's 2. D, that's negative 4. And m is equal to 3. Again, so 2 times 1 is 2. Negative 4 plus 3 is negative 1. 3 times 1 times negative 4, this is negative 12. Then 2 times negative 4 times 3, yeah, this is negative 24. Okay, and then we shall now have 2x plus 3 squared times x minus 4 to the negative 5. Then this is 2x negative. Okay, and then because of this negative 1, okay, and that's negative 2x plus negative 12 plus negative 24. Okay, and then we shall now have negative 2x, negative 12 plus negative 24, okay, sorry, is negative 36. And then by common monomial factor again, we shall factor out negative 2 from here. And then we shall have negative 2 times the quantity 2x plus 3 squared times x minus 4 to the negative 5 times x plus 18, which I believe this is the same answer from our previous method. Okay, next. Oh, what's this? Yeah, okay. So we shall have the derivative of 3x squared minus 4 to the 4th power times 3x squared plus 4 to the 3rd power. Again, applying the principle. So these are the derivatives of your u and v. This is our u, and this will be our v. And then we shall now have 3x squared minus 2 to the 4th power times 6x times the quantity x squared plus 4 to the 2nd power. That's our dv plus u. And then this will be our, this is our v. V, and this shall be our du. Okay, and then when you simplify that, we shall now have 6x. Okay, that's the common monomial factor between 6x and 24x, so that's 6x. And then we shall have 3x squared minus 2 to the 4th power and 3x squared minus 2 to the 3rd power. Common monomial factor is 3x squared minus 2 to the 3rd power. And then for x squared plus 4, this is x squared plus 4 to the 2nd power, x squared plus 4 to the 3rd power, and the common monomial factor is x squared plus 4 to the 2nd power. When these three factors are removed from the first term, we shall have 3x squared minus 2, then plus 4 times x squared plus 4. And then simplifying, you just copy 6x times 3x squared minus 2 to the 3rd power times 6x squared plus 4 to the 2nd power. And then this will now become 3x squared minus 2 plus 4x squared plus 16. And then we simplify further. Okay, so 3x squared plus 4x squared is 7x squared. Negative 2 plus 16 is 14. Yeah, that's 14. And then you can factor out 7 here. Okay. And then you multiply it to 6x. So finally, you shall have 42x times the quantity 3x squared minus 2 to the third power times x squared plus 4 to the second power times the quantity x squared plus 2. And okay, next. Find the derivative of the square root of 2x minus 3 all over 4x plus 1. So here, this can still be rewritten of this form, the quantity 2x minus 3 all over 4x plus 1 to the raised to 1/2. So this can be thought as derivative of power, but in this case, our u is represented by 2x minus 3. Okay, sorry. Our u is represented by 2x minus 3 and our all over 4x plus 1. So this is our u. And then to find the derivative of this, you can use this special formula. Okay, so we shall now have, for the power formula, so what you're going to do is to bring it in front, bring the power 1/2 in front, and then you subtract 1 from 1/2. And then you shall have 1/2 times the quantity 2x minus 3 all over 4x plus 1 raised to negative 1/2 times the derivative of 2x minus 3 all over 4x plus 1. And then to find the derivative of this, so we shall now have, I will write it here, derivative of 2x minus 3 all over 4x plus 1 equals, I'll just copy the denominator first, 4x plus 1, raise it to the second power. And for the numerator, we get 2, okay, 1, it's negative 3, and then 4 and 1. And then 2 times 1 is 2, minus 4 times negative 3 is negative 12. So this will become positive 14. So the numerator would have been equal to positive 14. And that's the derivative of 2x minus 3 all over 4x plus 1. And we shall now have, 1/2 times the quantity 2x minus 3 raised to negative 1/2 all over 4x plus 1. And that's it. 14 all over 4x plus 1 to the second power. Then simplifying, okay, so this is what I'm going to do. I will express by loss of exponent, I will distribute this negative 1/2 each term on the numerator and the denominator. So you'll have 14 times 2x minus 3 to the negative 1/2 all over 2, okay? 2, then 4x plus 1 raised to negative 1/2 times 4x plus 1 square, okay? And then simplifying, so 14 over 2, that's 7. Then, since this is negative 1/2, the power is negative 1/2, so you can bring it on the denominator to express the power positively. So that's 2x minus 3 to the positive 1/2. And then, by loss of exponent again, since this is 4x plus 1 raised to negative 1/2 and 4x plus 1 square, you can now add the powers or the exponent negative 1/2 and 2. And that will give you 3/2. Okay, so the final answer would have been equal to 7 all over the quantity 2x minus 3 raised to 1/2 times the quantity 4x plus 1 to the raised to 3/2. Okay. And I think this will be the last. Oh no, what happened to this one? Okay, yeah. So we wish to find the derivative of the square root of the quantity 2x minus 3 to the second power times the quantity x squared plus 2x plus 1 to the fourth power all over 3x minus 1 to the third power. Okay. And we can still rewrite this function as 2x by loss of exponent minus 3 raised to 2, then times 1/2. Okay, and that 1/2 is or it indicates this the square root. Sorry, and then times x squared plus 2x plus 1. This is a perfect square trinomial, okay? Perfect square trinomial whose factor is x plus 1 to the second power, okay, times 4, and then times 1/2 because of that square root, all over 3x minus 1 to the third power times 1/2. Okay, and then we shall now have 2x minus 3 raised to 2 times 1/2 is 2x minus 3 raised to the first power. And then x plus 1, then 2 times 4 times 1/2 will give you 4. And then on the denominator, we shall have 3x minus 1 raised to 3/2. So in this case, we shall now use the quotient rule. And when differentiating the numerator, we shall use the product rule and also the power rule. Okay, so we shall now have, okay, by quotient rule, we copy the denominator, 3x minus 1 raised to 3/2. Okay, and then you raise it to the second power. So that's v, 3x minus 1 raised to 3/2 times the derivative of this. So the derivative of this, you apply the u dv plus v du principle. And you shall have 2x minus 3 times 4 times x plus 1 to the third power plus the quantity x plus 1 to the fourth power times 2. Then minus 2x minus 3 times x plus 1 to the fourth power. This is the numerator. Our v, this is our u. Okay, times the derivative of v. Okay, that's 3/2 times 3x minus 1. Then 3/2 minus 1 is 1/2. Then times the derivative of 3x minus 1 is equal to 3. Okay, and then when you simplify that, you shall have this. That's 2 times the quantity 2x minus 1 raised to 3/2 times x plus 1 raised to the third power. I just use the common monomial factor for this one, for the first term. Then minus 9/2 times 2x minus 3 times x plus 1 to the fourth power times 3x minus 1 raised to 1/2. Again, by common monomial factor, you shall have this. And simplifying further, okay, you shall have this. And then simplifying further, you will have x plus 1 to the third power. And then I just combine this 3x minus 1 raised to 1/2 and 3x minus 1 to the third power. By laws of exponent, that is equal to 3x minus 1 raised to 5/2. And then you just multiply this, okay? And then multiply this 3 and then add the products, and you shall have 21x squared minus 71 all over 2x plus 47 over 2, okay? And then finally, just to avoid this denominator 2, I will multiply everything by 2 or by 1/2. I will factor out 1/2. So 1/2 times the quantity x plus 1 to the third power, okay? Then the 21x squared will become 42x squared minus 71x plus 47. And then all over 3x minus 1 to the raised to 5/2. And then again, to avoid this 1/2, I can write it of the form 1 all over 2, and then you copy everything. And finally, the derivative of the function, okay, is equal to x plus 1 to the third power times the quantity 42x squared minus 71x plus 47 all over 2 times the quantity through 3x minus 1 raised to 5/2. And let's see. Okay, and that's it for now.